Chapter 11 is all about gases, and one of the things that makes Chapter 11 a nice short chapter is there's one basic formula that describes the behavior of gases, and that formula is PV equals nRT, where P is the pressure of the gas, V is the volume, N is the number of moles, R is called the gas constant. It's 0.0821 and it has 4 units: liters times atmosphere divided by mole and Kelvin. And then the temperature T be sure you use the temperature in Kelvin, not degrees Celsius, not Fahrenheit. So the pressure P is something we can measure experimentally. We can use a barometer to measure, for example, the pressure in a room on a certain day. A barometer is made up of a pool of liquid, such as mercury, and then we put a inverted tube which has a vacuum at the top. So there's essentially nothing in the top of this tube. Atmospheric pressure pushes down on the mercury and it forces some of the mercury to go up into that evacuated tube, and the height difference between the pool and how far up it goes, that is the pressure. So 1 atmosphere of pressure is defined as the difference in height here being 760 millimeters if you use mercury as your liquid. If you use water, you can do the same kind of experiment, but the water being less dense, well, you need a much larger tube for that pressure difference. There are many more units of pressure, for example, pounds per square inch, which is how you measure the pressure in automobile tires. Many more units of pressure on your formula sheet. What causes the pressure is the random motion of gas particles. And we can understand that random motion and the other properties of gases if we think about a balloon. A balloon is just a sample of gas that's been captured, and we know that a balloon can easily be compressed. So between gas molecules, there is a lot of empty space. In fact, most of a gas sample is empty space. The gas particles themselves don't take up very much of the volume. That's completely different from a liquid or a solid. It's very difficult to compress a volume of liquid to a smaller volume. It requires a huge amount of force to do that because there's essentially no empty space between liquid molecules, and the same thing is true for solids. When we have a sample of gas, it fills the container completely, which is different than a solid or a liquid. If you pour a liquid into a container, it's going to settle by gravity at the bottom. It doesn't fill up the entire container. Like solids and liquids, gases are also in constant motion. And as long as we're talking about ideal conditions, ideal gases, which are gases that follow this equation, this is the ideal gas law or the perfect gas law. Ideal gases mix completely with other gases. Which again is different than, for example, liquids. Water and oil, you can pour them together, but they do not mix. If you pour oxygen gas and nitrogen gas together, they will mix completely.